Now we are going to start miscellaneous exercise on chapter 5. 5.1, 0.2, 0.3 ये तीनों exercise को already कर चुका हूँ. Now today we'll start this miscellaneous exercise. Okay. तो क्वेश्चन पहले देख लेते हैं किस टाइप का क्वेश्चन है, क्योंकि ये तो मिक्स्ड क्वेश्चन ही होगा. मिसलेनियस मतलब पहले मिल चुका है, ये मिल चुका है. ये क्वेश्चन नंबर 2, फॉर एनी टू कॉम्प्लेक्स नंबर Z1 and Z2 प्रूव दैट रियल पार्ट ऑफ Z1 Z2, ये एक्सप्रेशंस प्रूव करना है. और रिड्यूस टू द स्टैंडर्ड फॉर्म मतलब a प्लस IV फॉर्म में एक्सप्रेस करना है. और क्वेश्चन नंबर 4 में प्रूव दैट दिस इज टू बी डन using some properties, then convert the following in polar form. ये r and theta में एक्सप्रेस करना है और ये सॉल्व करना है. ठीक है, हम लोग का एक्सरसाइज में ये 13 क्वेश्चंस एंड 20 क्वेश्चंस. ठीक है, स्टार्ट करते हैं नंबर 1 से. क्वेश्चन नंबर 1 में ये है और इसमें है i to the power 18. इसको आप to the power 4 में एक्सप्रेस कर सकते हैं इसे. तो ये हो गया 16 और 2 चाहिए तो आप आई स्क्वायर से लिखिए. इसमें एक्सप्रेस करने का मतलब क्या हुआ, क्योंकि आई टू द पावर 4, बिकॉज वी नो आई टू द पावर 4 इज इक्वल टू 1 एंड 1 टू द पावर एनी पावर विल गिव अगेन 1 एंड आई स्क्वायर और आई क्यूब व्हाटएवर. आई क्यूब इज इक्वल टू माइनस आई एंड आई स्क्वायर इज इक्वल टू माइनस 1 and I to the power 4 is equal to 1. These are basic values with different powers of I, isn't it? 1 by I का मतलब minus I है, तो minus I to the power 25 होगा ये, isn't it? तो कैसे किया गया, I 4 मतलब 4 into 4 16 plus 2 18 हो गया, and then 1 by I is equal to minus I, then 25 4 into 6 तो 24 हो गया plus 1 so 25 and then this cube, then this mass is equal to 1 and I square is the remaining part. Then again here I minus I to the power 4 into 6 plus 1, so this is odd power, so minus is taken out and I to the power 4 into 6 plus 1 whole cube. Okay, then this is equal to minus 1, it is written, and then I to the power 1, because this is going to give 1 only. I to the power format is I to the power 4k. We know k is any integer, isn't it? Then minus 1 minus I to the power 1 whole cube. This one, right? Both minus can be taken common here. This one. Then inside bracket 1 plus I whole cube, expanding following a plus b whole cube formula, we get a cube b cube 3a square b 3ab square, isn't it? So like that, a cube b cube 3a square is this one, bi, isn't it? 3ab square. Following this expansion we got this. Okay, 1 cube is equal to 1, I cube is equal to minus I, this is equal to 3i, this mass is equal to 3 into minus 1 because I square is equal to minus 1. Okay, so we are having here 1 and minus 3. These two are real numbers and these two are imaginary numbers. So minus 1 is this one, 3i, then this is equal to minus 3, isn't it? So minus 2 using these two, and these two is equal to 2i. Now taking 2 common, we are having this one, minus 2 whole into minus 1 plus 1i. Okay, so next question number 2. Here, for any two complex numbers Z1 and Z2, prove the real part of Z1 Z2 is equal to real part of Z1 into real part of Z2. minus imaginary part of Z1 and imaginary part of Z2. So for this, any two complex numbers, so we can consider Z1 is equal to this, because any two complex number, we can consider any kind of complex number, isn't it? Then Z2 is equal to x2 plus I, y2, where x1, y1, x2, y2, all these are purely real numbers. Then x1 is a real part of Z1 and the real part of Z2 is this x2. Okay. Then imaginary part of Z1 is y1 and imaginary part of Z2 is y2, right? Then let us find out the product of Z1 and Z2 as we need real part of this number. So we must first find out product of Z1 and Z2, and this is what we are going to do here, right? X1 plus I y1 is because for Z1, and for Z2 is this one, x2 plus I y2. Nice. Now let us multiply these two as usually. So x1, x2, these two. Then y1, y2, I square. So minus sign is this one because of I square. And then y1, y2 is this. Then taking I common, imaginary parts are this one. How? I, y2 and x1 is this one. I, y1, x2 is this one. x2, y1. Isn't it? This I is not required here because it is taken common, right? You see, real part of Z1, Z2 is this one, this part, and this part is imaginary part, isn't it? Imaginary part of Z1, Z2, and this part is real part of Z1, Z2. Okay? So real part of Z1, Z2, we can write this x1, x2, y1, y2. Now x1. X1 is actually our this one. Here you see, real part of Z1 equal to x1. This x1 is equal to, we can write real part of Z1, and this x2 is equal to, x2 is this one, real part of Z2 is this. So instead of x2, we can write real part of Z2. Similarly, imaginary part of Z1 for y1, and for y2, this imaginary part of Z2, and all these things we have written here in this part. Okay, so real part of Z1, Z2 is this expression, and this is what is to be proved. ये प्रूफ करने के लिए हम लोग क्वेश्चन में देख रखा था, isn't it? Now question number 3 क्या देख रखा है? Reduce this expression to the standard form. Or standard form means a plus ib form is the standard form of a complex number. So we will simplify this to this format. Okay. For that, let us take LCM of these two, and this part will remain same. And taking LCM, we are having this 1 plus I, this here, and 1 minus 4y is this number, 2 into 1 minus 4i. Now 1 plus I is this one, minus 2, then minus minus, plus 8i. This is as it is. Then multiplying these two, 1 into 1, 1 into I, minus 4i into 1, minus 4i, and these two, 4i square. Simple. Then minus 1. Because 1 and minus 2 real part, and imaginary 9i. Okay. Then 1 is this one. From these two, we are having minus 3i, and this is I square minus 1. So finally, plus 4. So these two is giving 5 minus 3i. Isn't it? 5 minus 3i, minus 1 plus 9i. Okay. 3 minus 4i, 5 plus I. Now we can multiply these two numbers. See, minus 1 into 3, minus 1 into 4i, this. Similarly with 9i, we are having these two. Then with 5 plus 5i, 25 5i. Then with minus 3i, we are having this. So I square is to be replaced by minus 1, isn't it? So 36 minus 1, minus 1 into minus, so plus 36. Similarly, it is plus 3. Rest part, you see minus 3 is this one. Then imaginary 31i, and these 2 is going to give minus 10i, right? Then next you are having here 33, 31i, these two. Then in the denominator 28 minus 10i. Now 2 is taken common in this one. Then multiplying by 14 plus 5i, 14 plus 5i, numerator and denominator both, right? So here simplifying these things, we are having like this: 14 square, then minus 5a square, using this a plus b whole into a minus b is equal to a square minus b square. This formula has been used here for multiplying these two, and in the numerator we are applying normal multiplication. So this much we have got, and that, so simplifying this numerator we are having this, then in the denominator is this part. So 2 into 21, and simplifying we are having this much, and writing in a plus ib form we got this. Okay, so this is in our standard. Then number 4, this is given, and with the help of this we have to prove this much. So this is the property of a complex number: x minus iy is equal to this much, then x plus iy is equal to the same thing but with the positive sign like this. Okay, now 1 and 2 multiplying, 1 and 2 we get this much as it is. Then a minus b, a plus b is equal to this one, square minus b square is equal, we know, a minus b whole into a plus b, is not it? And here this is in the format of this part, so we are writing this way. Okay, now again a minus ib, a plus ib is also in this format. In the denominator is also in this form. So here this is x square, okay, and y square is also okay, but I square is equal to minus 1 with this minus 1 and this minus, so it is plus, right? Then a square, this is square, then ib square, then c square, and id square. Okay, in the next line x square plus y square is this one, and then applying this I square is equal to minus 1, we are having plus b square. Similarly here in the denominator it is plus again. Okay, now squaring both sides we will get x square plus y square whole square, a square plus b square by c square plus d square, which is to be proved. Okay, now question number 5, convert the following in the polar form. Let us see one of them, this one. Expanding denominator in the form of a minus b whole square, we are having this. Then simplifying all these things, we are having 1 plus 7i by 3 minus 4i. Then multiplying both numerator and denominator by 3 plus 4i. Multiplying numerator and denominator by 3 plus 4i. Okay, so this is done here, and this is a minus b, a plus b, so a square minus b square. So in the numerator it is normal multiplication, right? Simply you multiply. Then 3 square 9, 4 square 16, I square is equal to minus 1 with this minus 1 and minus, so plus. Okay, and then 1 into 3 3, 4i, 7i into 3 21i, then this is 28i square. So this is actually minus 28 because it is I square equal minus 1, isn't it? Then 4i, 21i, you understood this much. Next, minus 28 plus 3, minus 25, 25i. Then your number is minus 1 plus i. This is in standard form. Actually, our question is to express in polar form. So now we can proceed to find modulus and argument. This is your complex number where comparing with z is equal to x plus iy, we have x is equal to -1 and y is equal to 1. So this is our modulus of z, x square plus y square, which is giving root over 2. Okay. Then considering theta our argument, then tan theta equal to y by x, which is going to give 1 by -1. Then this point -1 1 lies in the second quadrant, isn't it? Therefore your argument is pi minus alpha, where alpha is where tan alpha equal mod of y by x. Okay, putting values of x and y, we are getting this 1045. Alpha is equal to pi by 4. Okay, and argument of z using this one, pi minus pi by 4, which is equal to 3 pi by 4. So argument is 3 pi by 4. Now, and this complex number in polar form, z is equal to root over 2 cos 3 pi by 4 plus I sin 3 pi by 4. Because you know, in polar form, cos theta plus I sin tan theta. Any complex number, z is equal r cos theta plus I sin theta is our polar form, isn't it? R is mode of z and theta is argument of z, right? Already we have got these two values, so putting this mod z here in place of r, we are getting root over 2, isn't it? Theta is equal to 3 pi by 4, so this is our number in polar form. Okay, thank you.